Welcome to my channel RLD Academy. In this video, I am going to discuss one example of H or hybrid parameters, and this is lecture number 7 on two ports network. So let us start with this problem. So you see here the problem given here, and it is a T network given. It is 1 ohm, this is 2 ohm, this is 2 ohm. This is input port V1, current I1, output port V2, and entering current I2. For this, suppose first I have to find out all the H parameters, H11, H12, H21, and H22 simultaneously. Okay, so for that, what you should do, you should write the equation. So you know that in H parameter, we'll express this V1 and I2 in terms of simply I1 and V2. Okay, so this coefficient is H11, this is your H12, this is your H21, H22. Okay, so this is a linear combination, that's all. So we need to find out all the ports H11, H12, H21, and H22 simultaneously, right? So we need to get these equations, that's all. Now as this is a T network, then we know that the Z parameter is very easy to compute. Okay, so what you can do, we can start with I1 and I2. These are currents, so this current is I1 plus I2, right? Now we can find out the KVLs at the input side and KVL at the output side. So we can find V1 and V2 first in terms of I1 and I2. Okay, I think you know that one, the Z parameter. So first one is I1 coefficient will be 1 plus 2 is 3, right? So 3 I1, and middle is 2, so it is 2 I2. Similarly, it is 2 I2, middle one. And then this one Z22 will be 2 plus 2 is a 4 I2. Okay. So if you have gone through my Z parameters video, then easily you can write this one, because the Z11 is this addition of these two, that is this one 3, and Z12 is middle one 2, Z21 is again middle one, it's 2, and Z22 is addition of these two, it's 4. That's simple, and that you can derive it easily. Okay, I know, I think you can easily find out this V1 is simply, if you take a KVL loop here, so 1 into I1 plus this current, this is 2 resistance, and current is I1 plus I2. So if you simplify this one, you will get this one, right? Because 2 plus 1, 3 I1 and 2 I2. Similarly, V2 in output loop, so it is 2 I2, the resistance is 2, here the drop is 2 into I2, and here the drop is 2 into I1 plus I2, right? Plus 2 into I1 plus I2, and that will give you this one, right? So it's very simple. Now you should understand in H parameters which are independent parameters. The independent parameters are these two, I1 and V2. Okay, so you should find one equation where you will get two independent parameters, both the independent parameters. So you see the first equation contains V1, I1, I2, but V1 and I2, these two are dependent parameters. So we can't start with this one. In second equation, you will see V2, I2, sorry, this is your I1, okay, V2, I1 and I2. And you see, this is actually the second equation, V2, I1 and I2 is there. So we can start from this equation. We can rearrange it to get I2. Okay, so what is this? So this 4I2, I can rewrite that it is V2 minus 2I1, right? So again, we can simplify it. So what is I2? I2 is this 4 I can divide. So this I1 coefficient first, right? So minus 2 by 2 is minus half I1 and plus V2 by 4, right? Then, so already you have got this equation, right? So I2 equals to some constant multiplied by I1, that is your H21. So H21 is half, minus half. And H22 is 1 by 4. Just you can equate this one should be equal to this one minus half, and the H22 is 1 upon 4. That's simple. And then if I replace in the first equation this I2 value, I'll get another this one, right? So now, so if I write this V1 equals to 3I2 plus 2 into, sorry, 3I1 plus 2 into I2, and I2 I can replace minus half I1 plus V2 by 4, right? So if you simplify it, what you'll get? So this 2 will cancel out. So it's minus I1, 3I1 minus I1 is 2I1, right? And this is 2 is multiplied here, so it is V2 by 2, right? So you see we have got these two equations. This is your V1. So if you consider this one here, so you will see this V1 we have got 2I1 plus half V2, and I2 I have got from here minus half I1 plus 1/4 V2. Okay, so H parameters we have got. So what are the H parameters? So these H parameters. So first element is 2, then half, this is minus half, and this is 1/4. It's very simple. So if it's a T network, then start with this equation V1 and V2 in terms of Z parameters. As you start with Z parameters, then rearrange one equation, okay, which one is containing two independent variables. That is here it is a I1 and V2. Second equation it is containing in this case. So if it is 5 parameter, you will start in different way. Okay, right. Okay, the next one, suppose same problem I want to solve in different way. Okay, suppose individually we want to find out H11, H12, H22, H21, okay, from the circuits only. Let us see. So what is the H11? H11 is, you see, you can remember that equations. Okay, that equation I write it again. So V1 equal to H11 I1 plus H12 V2, and I2 equals to H21 I1 plus H22 V2. So H11 is basically V1 upon I1 under condition V2 equals to 0. That I have discussed in previous lecture. So same thing I want to do. So V2 equals to 0 means what? This output side is 0, sorted. So that I'll do. This end I'll make it sorted. This is the condition, and then this is your V1 and this is your I1. Okay, so from here I want to get impedance from this side. So it is short circuit input impedance. Okay, and that is very easy to find out. So what is the impedance? So these two, you can easily see that these two are literally combined. So that will make you give you 1, right? So these two will give you 1 ohm parallel because this is 2 into 2 by 2 plus 2, that is 1 ohm. Okay, so that 1 ohm and this 1 ohm. So this 1 ohm plus this 1 ohm, total is 1 plus 1 is 2 ohm. So input impedance V1 by I1, that input impedance is simply 1 plus 1 equal to 2 ohm. That's all. This is your H11. So H11 is 2 ohm. Already you have got it. No? Right. Next one. So the H21 I want to find out. What is H21 again? H21 is I2 by I1 under condition V2 0. So this is I2 upon I1 under condition V2 0. Now again V2 0 means short circuit. I have to make it sorted. And then this current I'll consider I1, and this current is I2. This ratio I have to find out I2 upon I1. Okay, so how to find out if this current, now look at this figure, this is your I1, is entering current through this 1 ohm. Then there are two branching, so these are two parallelly combined, 2 and 2, so it is equally divided. So obviously this I1 is divided by these two paths. It is I by 2, I1 by 2, this also I1 by 2, right? So this is I1 by 2, this side. So this current is I1 by 2, but it is given the opposite direction I2. So I can write an equation that I2 equals to minus I1 by 2. Okay, so what is the gain? I2 by I1, this is minus half, and that is your H21. So H21 is minus half, right? Correct. And then H12, how to find out H12? So H12, you see this one, so reverse voltage again. So this is your V1 upon V2 under condition I10, and I10 means input side open. Okay, so this side I'll keep it open, don't connect anything. Okay, and then you have to find out V2 upon, so this voltage you will measure, that is your V1, and apply certain voltage here. This voltage you can connect, that is your V2. Okay, so if it is output side is input side is open, so this side is open, so there is no drop across 1 ohm. Okay, so it is a potential divider circuit. These 2 and 2, they are connected in series. So across 2 ohm is your V1. So what is your V1? V1 is potential divider 2 upon 2 plus 2 times V2. Okay, so what is your V1 by V2? It is 2 by 4, that is equal to half. Okay, so you see, so this is your H12. So H12 equals to half. Okay, so here H11 equals to 2 ohm. Here H21 is half. This is your current gain, forward current gain. This is your reverse voltage gain. Now H22, what is that? From this equation H22 is I2 by V2 when I1 equals to 0. So this is your I2 upon V2 when this I1 equal to 0. Means again I1 0 means it is open circuit, correct? And then you need to find out I2 by, so here you'll apply a voltage source, that is your V2, and this current supplied by the source is I2, and that ratio only. Okay, so that means from here what the impedance, so you have the admittance, you'll find out I2 by V1. Okay, so what the impedance, so this is not connected, open circuit, so this 2 and 2 is a 4 is the resistance, so admittance will be 1 upon 4. That's simple. So I2 by V2 will be 1 upon 4. So I2 by V2 is simply 1 upon 4. So that is your H22. So H22 is 1/4 Siemens or more admittance. So you see all the parameters you can find out individually. So in some circuits, in some problems, in GATE papers or other competitive exam papers, sometimes only one parameter is asked to find out. Then that case you can use this method, right? So now I can give you one homework. This is the first homework, problem 1, right? So just look at the problem. It looks a big network. And can you find H parameters? Okay. Is it easy? So I'll give you one hint to find out these parameters. Okay. So what you will do? So I think you have gone through my previous lectures, start to delta, delta to star conversion. Why not? You'll use that concept. So here, so can you modify this one? This pi network, can you replace by a T network like this? This means it's a delta to star. Okay, pi to T network conversion. I think that you can do. Then add the rest parameters. So, okay, this one you can add. Okay, and then you will get the equivalent T network. So this is already given 4 ohm. This is your 1 ohm, and you find this one, and this one, and get the T network. Then again, you can use the same method what I have done already. So can you find these 4 parameters H11, H12, H21, H22 for this network, big network? I hope you'll be able to do it. And if you get the solution, please post it in the comment section. I'll reply to your post, right? And one more problem I want to give you. Next problem is problem 2 as a homework. Can you solve this one? Suppose it is half ohm, Okay, this is your 1 ohm, this is a 1/3 ohm, right? And this is V1, this is your V2, and this one is I1, this is your I2. Can you find H parameters? Okay, that means all the H parameters, H11, H12, H21, H22, right? Now here I will give you one hint that as is a pi network, first try to find out the expression for I1 and I2 in terms of V1, V2, this combination. Okay, this coefficient, I think you can easily get it, right? I discussed Y parameter, okay, in my video. You go to this one, you can easily find out these values, and then consider one equation which will contain two independent variables, means both this one. What is that? I1 and V2. I think this one. So this equation you can start with, you can express V1, you will get the first equation, and replace V1 in the second equation, you will get another equation, and you will get all the parameters. That is one way. Otherwise, you can find out each parameter individually. That also you can try. So try to find all the parameters H11, H12, H21, H22, and post your solution in the comment section. Okay. I hope you have enjoyed this video. Then please subscribe my channel. It's a free subscription. I'm going to provide you many lectures depending on different subjects. Now I am discussing circuit theory. I've also covered signals and systems, okay, op-amp, all the things we are discussing right now, right? And press subscription button to subscribe my channel, and then don't forget to press bell button as well, because then only you will get the immediate notification of my channels. I think you are going to subscribe my channel and keep watching my videos. I'll be uploading lots of videos in this channel. Thank you very much.